Let's see another type of game, which is called two-person non-constant sum games. So let's see an example which is called the prisoner's dilemma. In this example, two prisoners escaped the jail and participated in a robbery, but they have been recaptured. But then the dilemma for these prisoners is like this. The police says that if only one of them confess and testify against the partner, the person who confessed will go free, while the partner will be given 20-year jail sentence. However, if both of them confess, then both of them will be convicted, sent to prison for 5 years. Finally, if none of them confesses, then they will be spending just 1 year in prison. Now, what should each prisoner do? Now, the assumption is that prisoners cannot communicate while making decisions. Now, let's point this out. If each player eliminates dominated strategies, interestingly, they will both end up with 5 years. Although you can see, if you look at the reward matrix, you will see that the best for them actually is both of them shouldn't confess, right? The sum of the sentence for them becomes just 2 years. But let's see what if they eliminate the dominated strategies. So for the role player, as usual, the role player cannot control whatever strategy that the column player will play. So we divide the events by saying that if prisoner 2 confess and if prisoner 2 don't confess. If prisoner 2 confessed, for the prisoner 1 or the role player, it is better to confess, right? Because if prisoner 2 confess but prisoner 1 do not, then prisoner 1 will spend 20 years in jail. So it is better to confess, right? If prisoner 2 do not confess, so this here, for role player again, it is still better to confess, right? Because between 0 and -1, 0 is better. So for prisoner 1, after eliminating the dominated strategy, or in other words, confess is always better for prisoner 1 against whatever strategy that will be played by prisoner 2. If you do the same thing for prisoner 2, you will also obtain that for prisoner 2, it is best to confess, regardless of prisoner 1 confesses or don't confess. But as I said before, this is interesting. When they both eliminate the dominated strategies, they both end up being sentenced by 5 years. And the sum of the sentences for them equals 10, while if they pick the dominated strategies, do not confess and do not confess, they will only spend 1 year in the jail. So the point -5, where both confesses, is an equilibrium point in this game, because neither player can benefit from a unilateral change in the strategy. So let's see how it works. So now we are at the point -5. Suppose if the column player changes from confess to do not confess, while the prisoner 1 stay in this strategy, then prisoner 2 will do worse actually. Prisoner 2 now will get 20 years, which is worse, right? Now if prisoner 2 stay in this strategy, but prisoner 1 moves away from this strategy, again prisoner 1 will experience something worse, which goes from 5 years in jail to become 20 years in jail. So none of them has the benefit to move away from this equilibrium point. Now let's try by checking if this -1 is an equilibrium point or not. It is not, because suppose we are at this point right now. If the role player changes from do not confess to confess, the role player will get the benefit from -1 in jail So from 1 year in jail to becomes 0 year in jail. Similarly, if prisoner 1 stay in this strategy, do not confess, but prisoner 2 moves away from do not confess to become confess, then prisoner 2 gets the benefit. That is why -1 is not an equilibrium point. Finally, this game is called non-constant sum games because the sum of the reward for each pair of the strategy is not the same. For example, the sum of this is -10, here the sum becomes -20, and here the sum becomes -2. You may compare this with the constant sum games where the sum of the reward for each pair of the strategy is always the same. Let's see another example. We have two competing restaurants and they are going to determine their advertising budgets. The combined sales for these two restaurants equals $240 million. And for the advertising, they can spend either 6 million or 10 million. So 6 or 10 for Hot Dog King and 6 or 10 for Hot Dog Chef. If one restaurant spends more money than the other, then the restaurant that spends more money will have the sales of 190 million. If both companies spend the same amount on advertising, then they will have equal sales, which is 120 million. Each dollar of sales yields 10 cents of profit. Now each restaurant wants to maximize the profit minus the cost that they spend for advertising. Find the equilibrium point for this game. Okay, so let's construct the reward matrix. So both restaurants have two strategies, spend 10 million and 6 million, and let's see this how we get this reward. So if Hot Dog King and Hot Dog Chef, they both spent $10 million, the sales would equal $120 million. From that sales, 120 million, the profit is 10 cents. So it's like 10% of $120 million, so 12 million profit. Now 12 million profit minus the advertising cost. 12 minus 10 is 2 for Hot Dog King. 12 minus 10 is also 2 for Hot Dog Chef. If they both spend if they both spend 6 million, it means that from 120 million sales, they get $12 million for profit. 12 minus 6 equals 6 for Hot Dog King. 12 minus 6 for Hot Dog Chef also equals 6. Now let's try to obtain this reward here, 9 minus 9 and minus 1. So here Hot Dog King spends more than Hot Dog Chef. It means Hot Dog King will have the sales of 190 million. From that sales, 19 million is the profit. 19 minus 10 for advertising equals 9. On the other hand, Hot Dog Chef only get $50 million of sales, right? Because 240 minus 190 for Hot Dog King equals 50. $50, the profit is only 5 millions. 5 million minus 6 million for advertising equals minus 1. So that's why you see 9 minus 1, 9 comma minus 1 for this part of the reward, and here minus 1 comma 9. Now the equilibrium point for this game is where none of the player has the benefit to move away from that point. So here the equilibrium point is 2.2. Because let's say we are at this point, and then if Hot Dog Chef decides to change the strategy, Hot Dog Chef will become worse, from getting 2 millions to become losing 1 million. Similarly, if we are at this point and suddenly Hot Dog King changes the strategy, now Hot Dog King becomes worse. Same as before, from 2 million becomes losing 1 million. So none of these restaurants gain the benefit from moving away from the equilibrium point. So we have seen from the previous slide that 2.2 I mean, is the equilibrium point for this game. It is interesting because similar to the prisoner's dilemma, if they both spend 6 million, actually they will get a higher profit after subtracting with the advertising cost, right? But somehow this competition makes both restaurants spend 10 million, and as the result, their profit actually becomes smaller. But why 6,6 is not the equilibrium point? Well, suppose we are at this point, 6.6. Then suddenly the role player says, I'm going to change the strategy from spending 6 million to become spending 10 million. Now, this hot dog king becomes better. So this point is not stable. Similarly, if we are at 6,6 and then suddenly the column player hot dog chef says that I'm going to change the strategy from spending 6 million to become spending 10 million. And then you can see that hot dog chef now becomes better. So you can see that 6,6 is not the equilibrium point. So in this example, two kingdoms are engaged in arms race, and their possible strategies are develop new missile or maintain status quo. Now here, if you develop a new missile, it costs 10 units. The cost is 10 units, but then if only one kingdom develops new missile, then that kingdom may conquer the other kingdom and earns the reward of 20 units. The conquered nation loses 100 units. However, if nobody developed any missile, then both of them doesn't win anything and doesn't lose anything. So that's why you see here, if both of them maintain status quo, then the reward is 0,0. However, if both of them develop new missile, both of them are losing 10 units, right? Because they need this cost of 10 units to develop new missile. However, none of them can conquer the other kingdom. So the reward here is minus 10, minus 10. So here it means that the first kingdom developed new missile, but the second kingdom does not. So the second kingdom can be conquered and it loses 100 units or $100. Then the first kingdom get the reward of 10 because by conquering the other nation it gets 20 units minus the cost of developing new missile 10 units, so it still get the reward 10 units. So here the reward matrix, and then we may show that the equilibrium point is located at both of them developing new missile. Again, similar as before, both of them actually may be in a better condition if they maintain status quo. They do not have to spend any money. Here, both of them spend 10 units of money, which is worse than spending nothing. However, 0, 0 is not the equilibrium point, because if we are at the 0, 0 point, one of them may think that, okay, now let me develop a new missile such that I can conquer the other kingdom. So here's another example of non-constant sum game in which the game is called chicken game. So Angry Max and James Bond, they are facing one another in a deserted road. They are driving toward each other, and then the one who swerves will be called chicken. Okay. But then if both of them do not swerve, they will both experiencing injury, I think, or maybe they will both die. So that's why the reward is minus 100 and minus 100. If they both swerve, they do not lose anything, they do not win anything, so the reward matrix is 0.0. But if, let's say, Angry Max do not swerve, but James Bond swerve, then James Bond will be called chicken and losing $5. In this game, the equilibrium point is if one participant swerves and the other participant does not swerve. So we have two equilibrium points here. To see why this is the case, we can see that if we are at this point, minus 100 and minus 100, then you can see that if James Bond suddenly changes the strategy from do not swerve to become swerve, he will experience a better benefit, right? From minus 100 to become minus 5. Similarly, if Angry Max swerve, he will experience something better from experiencing injury or even death to become just losing $5 of money. So you can see that minus 100 and minus 100 is not the equilibrium point. Similarly, if we are at 0, 0, this is not an equilibrium point, because if somebody changed the strategy, let's say James Bond changes the strategy from swerve to become do not swerve, then James Bond will win $5 instead of winning nothing. Similarly, Angry Max, if Angry Max changing the strategy from swerve to do not swerve, Angry Max will win $5 instead of winning nothing. So here you can see that in this example, the equilibrium is always one of the persons swerve and the other do not. So to finish the topic on two-person non-constant sum game, here's an exercise for you to try. Next week, we are going to talk about another type of problem which involves n people. Okay, so see you next week and thank you.